Okay guys, here's where it gets interesting. This isn't the toughest lesson I have, but it's going to be a little bit trickier, I think, doing it this way than the way that I normally would do it. So bear with me here. You may have to watch it a couple of times. I'll do my best, and also try not to make it quite as long. But I will give you a heads up as to the most complicated lesson I have. Anyway, okay, here we go. So we're going to be graphing absolute value linear functions, quadratic ones as well. And like I said, I'm going to try to take my time here. So it's going to seem like a lot, but like I said, we'll do a couple examples together. So if I were to ask you to graph y equals 3x, right, which you know is a reasonably steep line because the slope is 3, right, you would probably graph it using the y-intercept and the slope. But I want to be able to just do a comparison here. And so I always ask students to graph the basic one from, let's say, grade 9 and grade 10 before we do the one from pre-calc 20. So if I substitute 0 here, right, 3 times 0 is 0. Okay, and then remember this is not a parabola, so we don't have those mirrored points here. 3 times 1, 3. 3 times negative 1, negative 3, negative 6, and 6. So, I'm going to tilt this a little bit. You know what? You don't need to see me draw a line, do you? 0, 0, 1, 3, 2, and 6. Just want to make sure it's lined up properly. And it totally was not. 2, 3, there we go. So that's going to be the pencil line, all right? So we already know that. Nothing too terribly exciting, okay? So what happens, though, is we know that this can't be negative, right? We know that the concept of absolute value means distance. So what that's going to do is it's going to kind of mess with a couple of our points here, right? So there's nothing wrong with 0. 0 is clearly not negative, right? 0, neither is 3, and neither is 6. But what happens here? Well, we put the 3 times negative 1 and we get negative 3, and the absolute value of negative 3 is what? 3, okay? Oh, shoot. Nice. And then what this one's going to become? 6. I'm seriously going to have to resharpen that. Hold on, let me see if I can get a different pencil for that. Sometimes things do not work out according to plan. Just have to dig out another red one here. There we go. So as you can tell, it's going to look a little bit different. So I will plot. That's a little bit darker, but that's okay. And so I'm going to plot the 0, 0. Oh my gosh, it did the exact same thing. The good news is I have a lot of red pencil crayons, so eventually one should work. Okay, so 2 and 6, 2, 1, 2, 3, 4, 5, 6. Oh, thank goodness. 1, 1, 2, 3. Okay, 0 and 0. Now let's go over here. This time we've got negative 1, 1, 2, 3. And negative 2, 1, 2, 3, 4, 5, 6. So, and I know this concept continues in pre-calc 30. So this part, you can see I'm doing in 2 colors, but then all of a sudden it veers off course, right? And it goes up like this. And so if you look at what I've drawn in red, what have I drawn? I've totally drawn a V, right? So I'm just gonna do this. That's it, because I can't really slide it over here. So the shape of the absolute value of a linear function is a V. Okay, and so our domain, I am going to have to go back and forth. That's going to be interesting. Okay, I'm just going to zoom in a little bit so that I can get it all to fit in, otherwise I won't be able to slide it over. Oh, that's as far as it goes. Okay, well, then we'll just do this. Thanks. There we go. Okay, that's almost everything. So if we look at the pencil, right, the line, the domain, x is an element of reals. We already know that, right? Okay. And anytime we have a straight line that does not have a slope of 0 or an undefined slope, the domain is x is an element of reals, and so is the range. So if we look at the red V, what is the domain? Well, when I do the domain, that means all the x values, right? I look on the x-axis and I try to figure out, okay, if this is going to keep going forever and forever and forever in both directions, it will cross the entire x-axis. My domain is still the same. I picked out one of the broken ones. I tell you. Okay. Now, what about the range? This is where it gets interesting, right? And this can take us back to the parabolas, because we can see, if we look at the red V, that all of the y values on that red V have to be greater than or equal to 0. And, right, we sometimes sneak that in, sometimes don't. There we go. Oh, good grief there. Okay. So, new concept for us, not too bad. Are invariant points. And so invariant points are the points that are the same for both functions. So they're the points that are exactly the same on the pencil as the red V, and you can see where they overlap, right? And so those points will be all points where, and we just describe them in terms of x. So all x values, here's our x-axis. So all of the values to the right of 0, right? So x has to be greater than or equal to 0. And then last but not least, and this takes a little bit of practice, this next concept, so don't worry too much about it. It will continue with our reciprocal functions too, so it is important to get it. A piecewise function is a function composed of 2 or more separate functions or pieces, each with its own specific domain, right, that we put together to give one function. So what I need is I need the equation to represent this part of your function, which we already have because we already graphed it, right, when we graphed our line. But then we also need this one here. And so this is where it gets a little bit tricky. I'm actually going to do this one in pencil. And I'm going to try to zoom in here. So let's see if I can make that work. I'm just going to do it down here, actually. So y equals, and then we do this because we're going to have 2 parts. So the first part we're going to talk about is this part right here, this red part right here, which comes from our original line, which is y equals 3x, okay? Now this is where we have to be a little bit more specific. So that's part of it for all values where x is what? Well, we've already discussed that because those are our invariant points, right? X is greater than or equal to 0, okay? Now our other piece is this right here. So what we need to be able to do, and this goes back to Foundations in Pre-Calculus 10, is we need to be able to write the equation of that line. Well, it's decreasing. It's a decreasing line, so it has a negative slope, right? And so it will be y equals negative 3x. Except this time, we need to talk about our x values. And so our x values here, right, because here's our origin, and so all of the values here are where x is less than 0. Now notice I don't have that equal sign here. You can technically, I asked Mrs. Bowen this question, you can technically put it here or here. It doesn't really matter. You just can't put it in both. And I just usually put it in the first one. So I hope that makes sense. Okay. Oh, there's my other one. So let's just blow this up again. I'm just going to move that over a little bit. All right. I'm going to get a different color. Let's see. I'm going to try blue. Okay. So what do we know about this? And what I don't want you to worry about too much are this whole table here. I normally don't even do it the second time. Okay, and we're just going to talk about a couple of other things. So I'm going to talk you through this one as well, and then make sure you do the practice questions, okay? So we're going to graph the original function, y equals 2x minus 3. So I'm going to graph that 1 to negative 3, and then I'm going to do that slope. So run 1, rise 2, run 1, rise 2, And that's all I need in order to be able to make a straight line. So notice I'm not going to cover or fill in those numbers. I normally just do that with the first one, and I just have to change my notes. I just haven't done that yet. Okay, there we go. So already by this stage, you should be thinking a little bit about, okay, so now what's going to happen to our absolute value function? Okay, where is it going to all of a sudden turn into the v? Because this is important, right? So you could totally put in all those values for x, right? Just like we did in the first one, and I won't bring up the other one. It's where you have your x-intercept, right? Because that's where y is 0, right? And as soon as we go down here, that's when we have these negative values that we can't have because we're dealing with the concept of the absolute value, right? And so now this is where it kind of goes, oh, here we go. And so we're going to be graphing y equals negative 2x plus 3, right? Because it's the reversal of this one here. And so it's going to go 1, 2, 3, right? 1, 1, 2. And it's going to look like that. And it's super important to... So I have that. And then I have that as well. So again, it's a V, but you can see it's not quite as steep, right? Okay, so I guess I better zoom out again. Let's try that. See if I can fit that in there. Move that over just a little bit so you can see it. There we go. I think that'll work. Okay, so domain. Now, all these questions are of the of the absolute value function, so of the blue V. So for the blue V, we know that x can be anything. And the range, okay, again, you can see there's a pattern, right? Because every time it's like y is limited to 0, anything is greater than 0. So that won't change. The problem is once we get to the reciprocal functions, there's some really different things, and it's kind of easy to get mixed up. Okay, x-intercept, let's look at it. Where does it cross? So we can do two things. We can either look at the graph and figure out where it crosses the x-axis, or we can substitute y for 0 and calculate x. Okay, so it's halfway in between 1 and 2. So whether you write that as 1.5, I prefer improper fractions. Okay, coordinates of the y-intercept. Where does the blue V cross the y-axis? Right there. Make sure you don't do that one because we can't have negative y values. So 0 and 3. And so our invariant points are the points again which are the same on the line as well as the blue V. And so those are going to be all these points, and this is why our x-intercept is so important, right? Because instead of, in our first example, it started here, it's now starting here. So those are all the points where x is greater than or equal to 3 over 2 or 1.5 or whatever you have, right? Okay, so I'm just, oh shoot, that was close, almost dropped it. Just gonna move that over like that, blow that up just a little bit for you. So piecewise function is usually the trickiest part, and students get it, they just have to practice a little bit, right? So two equations for each part of the V. So the first one was y equals 2x minus 3. It's an interesting looking x. And for all points where x is greater than or equal to 3 over 2. And this underneath, this other one, right, which, I'm just going to do this, right, which represents this piece here, is the opposite, right? So it's all of the other x values, and then of course we've got a different slope and a different y-intercept. So we've got the y equals negative 2x plus 3, right? Opposite slope and opposite intercept for all points where x is less than 3 over 2. So I hope that wasn't too much, but by all means ask questions if you have them, and of course I'll post not just the answers I normally include, but the answer key, because there's a lot to this, right? All right, take care, and we'll talk to you guys soon.